It's time now to introduce one more formula for price elasticity of demand. And I know it's a lot to have two different formulas, but these formulas are really useful in two different situations. In the example we had in the last video, we had 2 points, price and quantity before, price and quantity after. So it made sense to use the percent change formula. But sometimes you'll also have the equation of a demand curve. And in that case, it's more useful to use an adaptation of this formula, which relies on the slope. I'm going to go through step by step in this video to show you that they really are the same. But you don't need to know that derivation. So at the end of the day, the only thing in your notes is this box containing the two formulas. All right, so I'll show you now how we go from percent change to slope. All right, so we've got percent change in quantity over percent change in price, which we calculate as new minus old over old divided by new minus old over old. So we have change in quantity over quantity divided by change in price over price. Remember that fraction over a fraction is not very nice to look at. So to simplify this, we can multiply by the inverse of the denominator. In other words, we're just going to flip this part around and multiply rather than divide. So that gives me changing quantity over quantity times price over change in price. And you'll notice here that I have two variables, just the level, and two variables in change form. I'd like to just rearrange these so that the level variables are together and the change variables are together. So I have, it's all multiplied, so it's no problem to just move those around. But now I have one term with the level variables and one term with the change variables. So we're almost there. Remember the slope of a line? What's the slope of a line? Rise over run. And in our equations, our rise variable is the P, our run variable is the Q. So the slope is equal to the change in P over the change in Q, right, as we move along the demand curve. You'll notice that this is something similar to this term, but upside down, the inverse, right? So this term in our elasticity equation is really the inverse of the slope of the demand curve. Okay, that sounds complicated. Now we can rewrite this formula to be a bit simpler than our original percent change formula, so it's worth it. We've got P over Q times 1 over the slope of the demand curve. That is our second formula for elasticity. And it's really the same formula, as you can see here. We've just rearranged it to be a bit easier to use when you're given the equation for demand, where you can easily identify the slope of the line.